as you have proceeded to make this into a biomedical instrument, we have focused on taking this resistor here, right, and making this resistor a function of temperature, right? That's how we got to the whole instrumentation idea, right? Let's review that. I said that there's this concept for all instruments, and I just love to draw this every class, okay? Every class I like to draw this, where we start with our sensor. We have here our circuit, and that is connected to a display. And I've made a point of starting to connect this here with two lines. In fact, this is going to be two lines as well, right? So that's how it works. And to relate this to that, you sort of just need to swap it around, right? Now, if you have a jar full of some sort of fluid, and you want to know what is the temperature of this jar, right? It is not a good idea to take this entire thing, right, and insert it into it, right? I mean, you're putting a battery into it, and now everything is floating around in a liquid. That is not advisable, right? So the solution is to have the sensor, let me just put S, which is inserted, while the remainder, let's call it our circuit, is out here. Now, what is our circuit? In this case, our circuit, and now we have two wires coming out of here, right? And let me do it. I'll invert the voltage divider. We'll still use our voltage source E. We'll have our fixed resistor, and we have created this, and here's our sub B, and so voltage would be measured here, right? Let's call it voltage of S or voltage of, right? So this voltage changes with R sub A, and R sub A changes with temperature. And that's something that we've covered before. That's really intuitive at this point. Now, one thing I think, but why am I repeating this here? I want you to notice this bit here, right? This is a cable, it's a wire. And so whereas the instrument, the main part of the instrument and the display, there's going to be a voltage divider here, we add a wire from here to here. And so perhaps your device is here, right? But you know, you have this wire, and the instrument is over here. But why can we do that? Why can't we just extend it out? And the reason is simply that, and it's obvious, but it needs to be said, that these wires have little, or we hope no, resistance. By adding the wires, we don't change the circuit. If they did, then I would have to redraw it this way. I would have S, and then I would have R wire, and of course another R wire, and then R sub B, right? I mean, so there is something so obvious, it's implicit, but I'm trying to make it here, that by making these small, right, by making these very small, let's say they're going to 0, it doesn't matter. Now, of course, you say, well, it can't truly be 0. Let's say R sub B is 10 ohms. And this wire is 0.01 ohms. So it still has a resistance. Will it interfere with this? Well, if this is a rather large resistance, and this is very small, right, then the R equivalent is not going to be influenced, right? So all this by a long way to say why we can get away with using wires in general, but specifically why it allows us to take the sensor and move it away from the equipment, right? Which is saying a lot of obvious things, but in a way that now starts to become relevant for instrumentation. Okay.